Well, here we are again, and what we're going to be looking at now is the rest of modules 10 and 11. I've combined 10 and 11 here on price elasticity of demand. So I'm going to pick up from where we left off at the end of last time we were together. We had practiced finding the price elasticity of demand in this particular example. So we're going to pick up right here looking at, that's not what I want, a couple of extreme examples of elasticity. Here we go. This is what I want to do. So we did this one. We did all the percent change. Let me get through all of this. You can go away. All right. So here we go. So more extreme examples of elasticity when it is all the way, like graphically, when it's all the way horizontal, if we're talking about elastic demand, and if it's all the way vertical, if we're talking about inelastic demand, what that exactly means. In a couple of different ways to describe that. So goods can be kind of in these extreme situations as well. One of those, not exactly an extreme, but sort of the in-between, is something called unit elastic. Unit elastic means the percentage or the percent change in quantity demanded is going to be equal to the percent change in price. In other words, for every 1% that price goes up, quantity demanded is going to fall by 1% or by the same percent. For every percent that price falls, that price decreases, then quantity demanded is going to increase by that same percent. So if the price increases by 5%, quantity demanded is going to fall by 5%. It's unit elastic. It all kind of, it's not to say it all stays the same, but they increase, or the price increase and quantity demanded decrease, or vice versa, is all happening in equal proportion as opposed to one of them being in greater proportion. And we know when we calculate elasticity that goods that are unit elastic are going to have an elasticity coefficient of 1. We have already talked about what it means if the elasticity coefficient is less than 1. That means that it's inelastic. If it is greater than 1, it is elastic. If it is 1, that means unit elastic. Goods can also be either perfectly inelastic or perfectly elastic. Perfectly inelastic, that means that any percent change in the price leads to absolutely no change in the quantity demanded. That means that people are going to buy the same amount no matter what. It does not matter what you do to the price. People are going to buy this particular amount. If you raise the price, they're still going to buy that amount. If you lower the price, there's still going to be that amount. So that, and in that case, you would see a perfectly vertical graph, just like the one that is shown here on this slide. It makes a perfect eye like that. If the elasticity coefficient is 0, that is the elasticity coefficient for goods that are perfectly inelastic. So we talked about if it's 1, that's unit elastic. If it's greater than 1, that's elastic. Less than 1, it's inelastic. But if it is 0, again, because what that means is when the price increases by 1%, then that means that the quantity demanded is going to decrease by none, that it's going to be the exact, it's going to be the same that it was the first time. Then goods could be perfectly elastic, okay? Perfectly elastic means that if there's any change to price, then the quantity demanded is going to fall to 0. Then people won't buy any of it. So these are kind of, again, they're sort of extreme examples where it's sometimes kind of hard to find real life examples, although there are some. But perfectly elastic means that at this price, we buy this many. If the price goes up, we're not going to buy any at all. And a perfectly elastic demand curve would be perfectly flat. It'd be perfectly horizontal. And in that case, the elasticity coefficient is infinite. And perhaps a potential example of something like this that I've seen people use before is like purple pencils. Okay. If the price of purple pencils goes up, like just the outside of it is purple, the price of that goes up, the quantity demanded might go down to nothing, because if people couldn't get the exact same thing just in a different color, then they're going to buy that and not buy the purple ones at all. Again, not a great practical example. Some of these extreme things, are a little bit on the not as realistic kind of side, but there are some examples that might fit into some of those categories. So things can be perfectly inelastic, perfectly elastic, or unit elastic. So next, what I want you to do is pause the video for a second and see if you can't figure out, how many are there here? There's 4. Figure out the elasticity coefficients of some of that are presented in some of these situations. Use that percent change in quantity demanded over percent change in price. Be careful with those percents. About multiplying times 100, you don't necessarily have to do that as long as you're able to remember the fact that you're looking at percentages, proportions here, and see if you can't find the elasticity coefficients for these situations and if they are elastic, inelastic, or unit elastic, or one or the other. So pause the video, work through those, and then I'll talk about what the results are. Did you pause the video? I hope you did, because this is something that just takes practice. You do need to practice this. This is one of the areas that I admit I'm not as confident on, because it just takes practice. It's not difficult, but it's easy to confuse, I think, if you're not super careful here. So let's take a look at the first one. The price of hats increases by 10% and the quantity demanded decreases by 50%. Now this one was already in percentages, so we didn't have to do any calculating of percent change. So I know that quantity demanded changed by 50%, so I could just put 50 over the 10, and that equals 5. So for that one, the answer is 5. And that would make it elastic for those particular hats. The second one, price of water increases from $2 to $3 and the quantity demanded decreases by 10%. Now the answer is already up there for you. It's inelastic at 0.2. And we got that by, again, I like to sometimes write on, I realize you don't necessarily have this printed out, but if you did, I like to put myself a little O over the old number, which in this case is 2, and an N over the new number, which is 3. So 3 minus 2 is 1 over 2. So that's a half, or 0.5. And that's my percent change in price. So that's going to go on the bottom. And I already know that my percent change in quantity demanded was 10. Okay, or 0.10 because it's a percent. So that is going to come out to 0.2, which makes it inelastic. Price of gasoline increases from $2 to $4. Quantity demanded decreases by 1%. So we already know that top number is 1%. And I could put it as 1% or 0.01. Which either one you're going to do, just make it consistent on the top and the bottom. And then, where was I here? Okay, so the new is 4 minus 2 over the 2, which is 1. So I'm going to put that 0.01 over 1, which is how I get the 0.01. That is less than 1, so it is inelastic. The price of gum increases from $1 to $1.25. Quantity demanded decreases by 25%. So I'm going to put 0.25 or 25% on the top. And then my bottom number, price, 125 minus 1 is 0.25 over 1, so over 0.25. So we got 0.25 over 0.25 over 25% over 25%. That equals 1. That means that it is unit elastic. So hopefully you either got the answers to those correct, or you understand now better what those answers ought to be. Okay. Now, let's talk a little bit about elasticity visualized. We've already kind of hit on this a little bit about how the slope is oftentimes going to look. Although, yes, demand curves have an elastic and an inelastic portion. This is what, though, you could expect to see. If you want to jot down these the sketches here, you could, or you can just sort of look at this for reference. Either way, this would be perfectly inelastic right here. Notice it looks like an I. It is completely vertical. The elasticity coefficient here is 0. Remember that a perfectly inelastic means that any change in price leads to no change in the quantity demanded. And we can see that here, because here's our quantity, whatever quantity this is. As the price goes up, that's still the quantity. It does not change. So whether maybe this is $100 up here or $1 down here, the quantity demanded stays the exact same. It changes by 0% when the price changes. Here is relatively inelastic. That means that it is inelastic, but it is neither super going in one direction or the other. That is where the elasticity coefficient is less than 1. And so it's steep. It is approaching vertical, but it never becomes totally vertical, but it's kind of steep there. This one is more unit elastic, or elasticity coefficient is 1, and just sort of makes a straight sort of linear curve. This one here is relatively elastic, so it is a lot flatter, the elasticity coefficient there being greater than 1. And this one, of course, is perfectly elastic. It's completely and totally flat or completely and totally horizontal. Elasticity coefficient is infinite. And again, what this is showing you is that this price, okay, if we go up or we go down, then the quantity goes to none. So only at that particular price will people buy any of that particular good. Okay. Remember, I mentioned this the other day, but the elasticity for price elasticity of demand, that elasticity coefficient is always going to be negative because of that inverse relationship. So either the percent change in the price or the percent change in the quantity demanded is always going to be negative. So your number is going to be negative. But for price elasticity of demand, we always deal with the absolute value. That's the only time we do that. Supply and the others are a little bit different. But when we're talking about price elasticity of demand, it is always only about the absolute value. Now I'm going to show you another way to calculate elasticity that's actually a lot easier. You can't always use it because you won't always have the information to do it like this, but I want to show you this kind of I wouldn't even call it a trick. This is like another skill you need to learn, but this is one that will save you a lot of time. So I encourage you, as well as learning how to do this, learn how to spot it. I admit that this is something I'm not good at a lot of the time. I forget sometimes to use what we're about to learn here called the total revenue test. This will save you a lot of time and energy. And a lot of the time questions are actually designed really for you to use total revenue test, not to go through all the math that we've been learning, although sometimes you will have to do that. So what the total revenue test is, total revenue obviously means the money that is coming in, okay, the money that is being made. And any firm is going to calculate their total revenue. It is the price that they're selling their good at times the amount that they sell. So the amount sold or the quantity sold times the price, that is your total revenue. But the total revenue test allows us to measure elasticity because it shows us what any change in price is going to do to total revenue. And what that price does to the total revenue indicates what the elasticity is. So total revenue is found like this. It is simply the price times the quantity. So the price times the quantity is the total revenue. Now, if demand is inelastic, then if the price goes up, the total revenue is going to go up as well. And if it's inelastic, then any decrease in price is going to make the total revenue decrease as well. And that makes sense because if it's inelastic demand, then the change in price, it's not the demand or the quantity demanded is not all that sensitive to it. So the price goes up. Yeah, some people are not going to buy it, but a lot of people still will buy that particular good. The quantity demanded does decrease, but only by a little bit. So so that increase in price means they're actually going to make more money in that case. The total revenue increases. If they decrease the price, then the total revenue is going to fall because the decrease in price does mean that quantity demanded goes up, but it doesn't go up enough to actually cause them to make more money. They would actually lose money in that case. This is one of the reasons why elasticity is important for firms to know, what they should put on sale or how they might ought to set their prices. They could use elasticity to decide if it's going to be worth their while to raise or lower the price. So those things would go in the same direction if it's inelastic. And as you probably have guessed, if it's elastic, then they're going to move in opposite directions. So a price increase is going to cause the total revenue to decrease. So if something is elastic, a firm might decide it's not a very good idea to actually raise our price because our total revenue is going to fall in that case because that's elastic demand. The quantity demanded is going to be very sensitive to that change in price. When they raise the price, a lot of people just aren't going to buy. So even though the ones that you are selling, you're selling at a higher price, it's not going to make up for those sort of lost sales with that reduction in quantity demanded. And therefore, the opposite of that, a price decrease actually causes total revenue to increase. So these are the things that you want to put on sale, perhaps, at least some of the time, because when you cause or have that drop in price, the quantity demanded will increase such that your overall revenue is going to increase, even though the price is lower. Now, what some people always look at you funny, and it's a little weird, but a test you can use for this, and some teachers, make their kids do this more elaborately than I will, but you can always just use your arms for this. You can use your arms, or sometimes I just kind of do my fingers like this, but really arms are better. So if the price goes up and your total revenue goes up, both of your arms are up like this, you look like an eye, that's inelastic demand. If the price goes up and the total revenue goes down, you don't look as much like an eye, so that's elastic. And the same thing with elastic, if the price decreases, put an arm down, and the quantity and the total revenue decreases, you look like an eye, that's inelastic demand. So you can do your arms, or sometimes I just kind of do my fingers so people won't look at me strange. But use that total revenue test. I admit that, again, I sometimes just kind of forget to try total revenue test, and I'll end up doing all this math. And then later I go, oh, I was supposed to use total revenue test, and it was a whole lot easier. So this graphic is just explaining the whole concept I've just explained on the previous slide. It's just kind of helping you see it a little bit better. So here we have relatively inelastic demand. Here we've got relatively elastic demand. So as far as what happens to the quantity when when the price increases. Well, let's see here. So these yellow boxes represent the total revenue area, the area of total revenue if the price is at this level, whatever this level is. If I'm looking at both of them, let's just say that's $5. Okay. So there, that yellow box there represents total revenue. So what happens if we raise the price? Okay. With this inelastic demand, we see total revenue is now a bigger box than we saw before. With the elastic demand, we raise the price, and now that total revenue box is a lot smaller than it was before. So it depends on the elasticity, whether or not raising the price or lowering the price is going to mean more revenue or not. Okay, so now let's take a look at this question. I want you to take a second to find between A and B, is it elastic, unit elastic, or inelastic? But this time, don't go sit there and go through the math and the numbers. You can go back later and do that if you want to check yourself, but use total revenue test to figure out if this is elastic, inelastic, or unit elastic. So do that for a second, and then we'll go over the answer. Pause the video. All right, so let's take a look at this. So we have at point A, the price is 10, the quantity is 100, so the total revenue there would be $1,000, okay? And then B, we have $5 and 225 that are being sold, so price times quantity there would be $11.25. So overall, my price went down from A to B, total revenue went up. So price decreased, down, total revenue went up. I don't look like an eye, so that means that the demand is elastic in that point. But be looking for, whenever you have one that is phrased such as, when something is this much, we sell this many, and when it costs this much, we sell that many, use total revenue test. Whenever it's giving you price and quantity in the particular problem like that, or in the setup, go ahead and try total revenue test and see if that's what you need. Sometimes if it's asking for an elasticity coefficient, that won't be enough. But if it's just asking if it's elastic, inelastic, or whatever, then total revenue test can oftentimes work for you there. Lastly, to wrap up, let's see of this particular question. This is another one where you can work it out a couple of ways. Look at this one, work it out, or find the answer, and let's see if you got it correct. So if you got elastic as the answer to that, you are correct. And on this one, you can try to work it out. Let's see, total revenue test. Yeah, you can use total revenue test on this one as well, or you can do your percent changes, but it is elastic demand. So we will be looking next time at elasticity of supply, and that version of elasticity I think you'll find a little bit easier, only because now that you've learned price elasticity of demand, it's pretty much the same concept. Now you just have to apply it to supply and also cross price and income elasticity.